This is Mario with MIA Microflight once again, and continuing some videos on this project right here. These are some new sketches that I just printed of the particular go-kart that I am trying to build here. I'm not trying. I'm going to build it. Let me put it that way. Okay, so as you can see here, this one has a new layout for the control system here, which is the basically the hoverboard in front. There are plenty people that have done the same thing of putting, what I mean by the same thing, I don't mean in terms of the style here, the frame style, that's mine. The placing of the hoverboard in front of a structure that they can maneuver the hoverboard, you know, with their feet. The reason for those high chairs, I was analyzing some of these videos and structures, is that you need to have a high seating surface if you're going to do that, because the hoverboards operate with people standing on them on the hoverboard, and so those controls need to be with the person standing up or with a vertical pressure on the surfaces of those contact switches that are part of the hoverboards. So in order to get away from that and go a little more on an angle, you have to install some kind of a bracket that has the foot pedals on an angle. Oh boy, these mosquitoes, you know, I come into my shed and they're lingering here, these vampires. So I just sprayed myself with some of the mosquito repellent. Jesus Christ, they always get me. Okay, I should be immune to them from so many bites that I get from them. Luckily, I'm not allergic to mosquito bites, but you know, there's still, you know, it's uncomfortable getting all these bites and being itchy all the time here. Anyway, so I was saying that the reason for some of these hoverboards having those chairs up high is because the pressure needs to be vertical on these hoverboards. And so what I've done here is I've done the obvious thing, the logical thing to do if you're going to sit low on this, is to bring the surface of the contact point on an angle. And so I made these brackets here. This is my drawing for making the brackets. Like I say, it's a logical thing. It's not so much you know, a copy of anything that's out there. I have seen some hoverboards where people have installed these foot rests on an angle for the same reasons that I'm doing this. And like I said, this is just a common sense, logical thing to do if you're going to, especially if you're going to bring the seat much lower than than even some of these hoverboards that just have the seat. You know, like I showed in my other videos, you know, that the ones that are for sale, which is this hoverboard adapter here. You know, this is in line with the footrests, but of course the hoverboard is sitting at the back. And so the idea was to make this more in the shape of a go-kart. You know, so I'm doing two things that nobody's doing out there. I've searched high and low to see if anybody's doing the same thing. If, you know, somebody's doing the same thing, I wouldn't be doing these videos. Why waste my time, you know, when somebody else has done this? So this is and I guarantee anybody that's watching these videos, you know, to go check and see if there's something similar to my frame style. Number one. That is my own, and I explained that in other videos why I did that, and for you know, for a few reasons. And now I'm talking about this conversion here that I had to make these brackets, you know, to adapt these hoverboards so that it fits in a similar way to the way the one that I just showed, that commercial hoverboard adapter is done, you know, with a pin at the center of the frame to allow the front section to pivot, or to allow that front caster wheel to pivot. So we're basically doing the same thing. There's no magic. There's no you know, there's no new invention there. You know, it's a pivoting point that logically has to be there, you know, to allow these things to maneuver left and right. I mean, it's common sense. So the footrests, like I said, there is I think that there's another, there's a few videos I stumble on, you know, where people have also footrests, and I go, oh man, you know, people are thinking along the same lines. Granted that those videos came out a while back, and I'm just getting into this because I do have the time to do these things now, and I'm just doing this for fun. I'm not doing this for sale. I'm not trying to market anything here, and that's the reason why I'm showing my videos and my frames and my ideas here, freely. This is made, from my EMT tubing and maker pipe connectors, so there is a bit of creativity here. And I said in my other video that I wouldn't mind if maker pipe connectors, if they stumble on these videos, they lift this and put it on their website. More power to them if they can do that, just to show, more creative ways to use the EMT tubing and maker pipe connectors, which is what I'm doing here basically. And because I really like these connectors, they make building things a lot easier. And if I get tired of this, I can always disconnect this, take it apart, and I'm not stuck with a welded frame. Although I do like welded frames, and I've been welding a lot of things lately. This is, I'm going to show you, is a part that I welded, and I had to do that just to establish these footrests, because there's nothing that you can buy that's readily available that you can do this, independently, as you do with go-kart parts. You can buy spindles, you can buy brackets, you can buy steering mechanisms, you can buy all sorts of things to make the full go-kart. If you want to customize it, nothing like this exists at this point. And if there's a company that comes out, with individual footrests like this, great. Like I said, I'm not in the business of replicating this for manufacturing, for sale. And so, if anybody wants to basically do the same thing I'm doing, with these maker pipe connectors and EMT tubing, great. Just make sure that you link to my videos and you say, where you got that information from. Be honest about that. As I am honest in my videos in saying that I have stumbled on similar ideas, and although those ideas are inspirational in a sense, they're more reinforcement to some of the common sense, logical approach that I already was thinking along, when I did this. When I do this on the sketches on the paper, and then I put all kinds of ideas, and everything just works out from a logical step-by-step form, and then I do it on the computer, and then I realize these things in a real thing. So this is where I'm at right now. Pardon, I'm also a little bit nasal here, and so I think because even though I'm wearing a mask, when you work with cutting metals and welding, it gets, some of that stuff, it does get to you. I think, and I hope I don't plan on doing this all the time. So, just for health reasons, there is a risk, when you weld, when you cut things, when you work in dusty areas, even though, if you protect yourself. So, but getting back to this, here's another view of the go-kart, and you can see how very, very slick this is, and the way I did it. I made this narrow because I didn't want this to be too wide. There's a main reason for that, and it's to establish a maximum pivot and stop point when this whole assembly here rotates at the center here of this bar right here. When that rotates, this is going to come around here, and it's going to hit this portion here if you go over way too far, and the same thing on the other side. And so this distance right here establishes that much throw on the steering. If I would have made this a little bit wider, it would limit, to a much lesser angle. And so this angle, what determined this distance, basically what I'm trying to say, is the angle, the steering angle, more than anything. So that's what establishes this distance, and I believe this distance is, if I'm not mistaken, this is about 6 or 8 inches. And did I put that down here? Yeah, the dimensions are there, but they're in white numbers. I can't tell, but it's about 6 to 8 inches in distance. And so that keeps that nice frame really cool, spiffy looking. It's not just a bar. I could do this also with a bar. In fact, I'm going to test this on my on the track that I did with just a bar, the T shape that has that large caster wheel. I'm going to remove the caster wheel and put this there just to test the assembly. And then I'm going to do this right here with the empty tube because I really like the way this is coming out. I will be embellishing this further once I get this working, the mechanical, the steering to my liking. I will be embellishing this to with a rear termination here at the rear. This also needs a bar. I don't have the bar there, but it's not necessary because I'm focusing right now on this section right here. This is the more important things. So I didn't take the time to complete this drawing, but I will be completing this, and I will be embellishing this with lights. This is also going to have a front panel. That's the other reason for this angle right here. It'll going down. It'll have a front panel. It'll have the switches, and I plan on bringing. This doesn't have a battery. None of these hoverboards that I obtained to do projects like this have batteries. And I prefer them not to have the battery inside because it's a lot easier for me because I use Ryobi batteries too in series 18 volts, which is what these things run on, 36 volts total. You're better off with a separate battery, and if you can put even a higher amperage battery, those are the ones that I use are 4 amp hour, which give me about 11 a good solid 10-minute run on the go-karts that I've been showing in my previous videos. So but on something like this that's a little bit lighter, I should get another 3-4 minutes, maybe 5 minutes at the most. So this will have the control panel here, and also will have the battery support. My switch will be the on-off button. I won't have any charging jacks. I don't need them because those batteries they have their own chargers. But they will have switches similar to my other go-kart, the one that I did with 1.5 inch square tubing, where I did that control panel on the front. It's got the main switch, on-off switch. Then it's got forward, reverse. It's got the 3-speed or 3 high, medium, and low speeds. Also has reverse. It has cruise control, and it'll have lights, for the front and the front and the back. In the front, I want to have to figure out a way which is not very difficult because all I need here is a bracket, just a T bracket here for a maker pipe connector. Raise it, put a horizontal bar, and mount my lights right there for the front. Same thing at the back. I'm going to terminate that really nice and put one of those strips that I put on my other go-kart for stop lights and just regular back lights. So it's going to look pretty cool. I may do some kind of a handle here so that I can just hold on to while I'm steering this, because it would be beneficial to hold on to the something, to the car, something a little more permanent. I could also put a steering wheel like I showed in my other drawing. I don't have that drawing here, but I showed a steering wheel that could be attached to this thing that moves along with this whole assembly. Something you can hold on as you're steering, just like a regular go-kart. But those are additional things. For the time being, I'm just going to do it like this, and once this is done and proven, well, not so much proven because I do know that these things work. It's just that the angle of the footrest is what I'm concerned with, so that it's comfortable, so it's not it's not awkward and you're not in an angle where you're going to get tired. Those are the other things that I also look at that I'm pretty sure a lot of people don't consider those things when they build these things. They just put a chair there, and then if it works, it works. They're not concerned about ergonomics. I take all those things into account. Being that I am an engineer, I'm not a mechanical engineer. I'm an electronic engineer, but may as well be a mechanical engineer as well as aerodynamic, because I understand all those areas very well by getting my hands dirty and doing these things, building models. So there's so much information you can get just by building models and testing them in a scale format before you go to the real thing. And so that's most of my knowledge when it comes to these mechanical and aeronautical things comes from that type of experience. I didn't go to school to learn mechanical engineering. I didn't go to school to learn aerodynamic engineering. I do have a degree in electronics, but I'm once you understand that, I guess anybody in those shoes would that has that approach, that mentality, can pretty much approach any sort of engineering problem with equal force. So that's how I do these things. So I do take also ergonomics when it comes to these things. I want comfort, I want efficiency, I want comfort, I want, things that all those things that should be considered. When you do, if you were to make a product like this for the market. Like I said, once again, I'm not doing this for the market. I'm doing this for my personal enjoyment and for my kids' enjoyment, or somebody that just wants to ride it. I get a lot of joy by watching other people get into my contraptions here and doing it. It's not just myself that I get enjoyment from. I think I get more enjoyment out of seeing somebody really enjoy what I have built, what I have designed. And that's the reason why to this day I'm still selling the micro lights. I still get orders for the micro lights, ultra lights. And although many people are kind of private, they keep it to themselves. I do get often, not often, but I do get once in a while videos and photographs of customers that send me photos and says, "Hey, Mario, check this out. It's looking really good, and I finally got it to fly it and stuff like that." So I truly get. Those are, I would call the rewards of your efforts, that when you see other people enjoying. I can enjoy this and I can lie to you and say, what, this works this way. It's awesome. I mean, I'm not lying, but I could embellish this really to nauseam, in a video. But I don't like doing that. None of my stuff is done that way. I like to be honest with these things, and that's the reason why I'm selling. I'm showing these videos. From this perspective, I'm being totally honest. When I say, where my ideas flow from, and how sometimes I get inspired by seeing others, with similar ideas that just only reinforce, with the direction that I'm in. So anyway, I wanted to just introduce these things in this way, because right now, okay. So now that we have seen that, it's probably going to make more sense, to show that assembly right there. You can see the oh, I have this backwards, darn it. It should be like this if you were sitting in the cockpit. Okay, and so I just put those pieces together. The footrests with what would be the brackets for the hoverboard. That distance right there, I had to cut that bar and kind of shave a little bit at a time, because this has to sit right on top of those contact points on the hoverboard. And this distance is about 15, I think it's about 14 and a half, 15 inches, center line to center line. So so that it fits inside the most hoverboards. I wanted to work with most hoverboards, and most hoverboards are basically the same dimensions. So yeah, I did this section right here. As you can see, my welding is I'm not a professional welder, but I get by. The only problem with this welding this tubing is that this tubing is I believe 1/16th or maybe 50 thousandths of I should put a caliper there, but I think it's 1/16 wall thickness. The thickness of this metal is 1/16, and if your welding settings are too high, you're going to melt right through that metal. It's not going to build it's not going to build a nice puddle as you're I'm using the wire welding. I think that's called MIG welding. Like I said, I'm not a professional welder, and I'm still getting familiar with some of these practices here. But at least I have been successful. So with the thicker metals, like I did my C brackets on my other Go-Kart, those are like 3/16 inch in thickness. So it was a lot easier for me to just go around in circles, building the puddle and just taking my time. My son-in-law is he's done welding, and he's I would say he's more professional in that respect, because he's done that for many years. So he was kind of gave me some tips. He said, you have to go really slow, with the thick material, just to build the puddle. And so that, I took those things into account when those brackets. And same thing here, but the problem is that this is very thin, and you got to tone down the settings on the welding machine, so it doesn't go right through the metal. And I already went through this part right here. It started to eat this metal. This is nothing more than a half of this square tubing, this that I have quite a bit of this 1.5 inch square tubing. So I cut that in half, and I made these footrests from that, cutting also the on an angle the sides here. You can see how this one I actually built up the section by putting a piece of metal on top and welding that, and then coming back with a grinder and grinding that. But it's pretty solid. Then I came back and I did the inside as well, and you can see how I dropped some a little bit of not a little bit. I think there's quite a bit of there was quite a bit of quite a large puddle of metal there just to reinforce the back. And so I don't think these things are going to go anywhere. You know, it's pretty solid. So these parts are actually drilled right there, and these are going to go with a bolt right through that. I have to enlarge that hole and put that bolt right through. You can see this is a shoulder bolt. I guess they call these. They have this smooth surface, and this is to allow the metal to ride on that smooth surface, which is what you want, you know, on pivoting things like this. And this will engage into a nut here, which I'm going to weld. I'm going to put a washer there, and then I'm going to put a nut, weld all that so that I can lock these, not so much lock these things, but I just want to thread this in there. And it doesn't matter if it's fully threaded all the way or you know, not all the way, because all this is doing is actually this will be threaded all the way, now that I think about it, because it's got this shoulder smooth surface. So this will be pivoting on that surface here. So this can be locked into that. I can also weld this if I wanted to, you know, to just this bar right here. This bar right here will have to be drilled at the center, and this is going to attach to the center point of my frame where it pivots. So I'm going to test this, like I was saying, on my on that T structure with the caster wheel that I have, that large caster wheel. I'm going to remove that, and I'm going to put this here, and I'm going to test this. Once I get you know, I'm pretty confident in these angles, because I thought about this, and I was playing around with that, you know, just kind of sitting down and testing where my foot rests, you know, to get these angles right here. So I'm pretty confident these angles are just fine. They're going to be comfortable from this low seating point right here up to this point right here. So it's going to be comfortable. That once I test it, I don't think that I'm going to have any issues. And once that's done, I'll come back and build this frame right here and then complete this project. So this is Mario once again. This is where I'm at. Just another thing that I wanted to point out is this wheelchair. I stumbled on this wheelchair a few years back. It's a brand new wheelchair, believe it or not. That somebody dumped that in one of the dumpsters in one of these commercial buildings. I was driving through one of the alleys one time because I wanted to take a shortcut coming back from Home Depot near my home here. Excuse me. And I stumbled on I saw something sticking up this dumpster, and I go, well, that looks like a bicycle. So wheels were sticking out, and it wasn't a bicycle; it was a wheelchair. So it's basically brand new. There's a little bit of rust that has developed on some of these bolts from I've had this I don't know, maybe 3-4 years in another shed, and I decided, you know, I'm going to bring it out so at least it's in my view, so that I can get some ideas flowing. I mean, there's so many good parts here. There those wibbles right here. You can build. I was planning on building a lanyard from all these parts, you know, back when I got it. But now that I'm building these go-karts, I think I can do something pretty cool with this frame. Why am I doing this? Why am I doing this? I got to come back here because the sun is beating pretty hard here. I don't know. It's a lot of fun. I have the time to do these things, and I'm just having a ball, you know, building these things. And hopefully, you know, people that are looking at the stuff that I'm doing are also enjoying some of these videos. You know, I am a little bit slow in the sense that I make these videos one at a time as I'm going through the process, and not so much as pausing the video, coming back, doing a little section. You know, there are a lot of builds out there that they give you, you know, the full start to finish in one video that takes no more than maybe 15 minutes. I just don't work that way. I prefer to do videos on a daily basis. It's like I said, I do this not so much for views, but for more for it's a diary of what I'm doing here, so that if my family, my grandkids, somebody in the future stumbles on this, can see what I've done. That's I guess that would be the best way to put this. Anyway, Mario, once again with my amateur flight. Stay tuned for the continuation of this video or this project.